Alright, so we're going to do right triangles again, but with applications. So word problems, basically. And you're going to set up a triangle every time and use SOHCAHTOA to solve. If you read the first problem, a tree casts a shadow 32.6 feet long when the angle of elevation to the sun is 37.2. How tall is the tree? If you draw a line that represents a tree, you can actually draw a tree, whatever you draw a tree. You draw a tree, it says it casts a shadow that's 32.6, so it tells you the shadow. Now, of course, depending on which side the sun's on, but I'm just going to draw my shadow always to the right. So here's my shadow, and it tells you it's 32.6. This is the angle of elevation to the sun. Where would you measure the angle of a shadow? On the ground or in the sky? On the ground. So here is your 32 degrees angle. Yeah, you say 37. Sorry. Then the question is, how tall is your tree? So the mark I'm looking for is here. In order to earn credit for these triangles, I have to have a triangle. Okay? So that's your first step. And now then, if you look at the angle it gave us, and the cool thing about SOHCAHTOA and right triangles is that you can actually find missing pieces of a triangle, if you have a calculator, with only one angle and one side. Right? That's what's neat about it. So I only know one angle of this triangle and one side, yet I'm still able to find another side. If you look then, this is my angle, and it has given me the information in the problem. It gave me opposite over here, and it's adjacent. Those are the two pieces of info I have. And I mean opposite of the angle. So opposite of the angle and adjacent to the angle. If I'm using opposite and adjacent, what form, remember SOHCAHTOA, opposite and adjacent means I'm using what? Tangent. So tangent of my 37.2 is the opposite measure, which is my x, over my adjacent measure, 32.6. Remember from yesterday. Now, okay, for requirements, if you have this triangle and this equation, you're good. Now, in your calculator, the next step you don't actually have to write. In your calculator, when x is on top, that's the easy problem. So then that means that x actually equals the tangent of 37.2 times 32.6. That's what you're going to type in your calculator. And you should have gotten 24.74, right? So the actual height of the tree is 24.74 feet. Don't forget your unit of measure. Yeah, if you round it to 5. I mean, as long as you have the nearest 10. That's close.
Honestly, I thought it was like old buildings.
For an observer, 150 meters from a building, the angle of elevation to the top of the building is 12. How tall is the building? Read it again to yourself. So here's your picture. There's my building, and I have an observer. The observer is way over here. Okay? How far away from the building is he? It told me. He is 150 meters. And this is the angle of elevation to the top. Well, he's at the bottom, right? So he's saying from where he's standing down here all the way to the top of the building. So there's my 12 degrees. And I want to know the height of the building. It's a right triangle, that's why this works. The angle it gave me, and guys, they aren't all the same. So even though the first several are the same, it's just to kind of get your feet under you, right? So you've got to be sure you are careful. This is the angle. What it gave me is x counts as my opposite this time, and this is the adjacent. What does opposite and adjacent use? Tangent, excellent. So tangent of my 12 degrees is going to find me opposite over adjacent, so x over 150. Again, in your calculator then, you're just going to do tangent of 12 times 150. So the height of my building is 31.88 meters. Now number 3 is very similar. So I'm going to pause it, let you try it, and then we'll do number 3. Alright, so a point that's 289 feet away from the base of the Sears Tower. So here's my Sears Tower. You'll notice I've been drawing my triangles to the right. It doesn't make it correct, it's just a way to do it, okay? So here's my Sears Tower, and it's a point which goes here is 289 feet away. The angle of elevation to the top is 48 degrees. There's my right angle, this is 48. Find the height of the building. So it's the same exact problem again, right? So by now you're probably pretty good at these. Opposite over adjacent means I'm going to need to use tangent. So tangent of 48 degrees. The opposite of this angle is x. The opposite and the adjacent to this angle is 289. You always use opposite and adjacent in reference to the given angle. Okay, what's opposite and adjacent is dependent on what angle you use. This side isn't always opposite. This side isn't always adjacent. It's just opposite and adjacent to 48. Okay? So then x ends up being 320.97 feet. The amount of work shown I have right here is what you need. Alright, number 4 gets a star. You've done enough of the same, so let's move on to something harder. You can't do 4 the same way. I'll give you a second to read it. The angle of depression. Okay, what does that mean? Instead of being on the ground and looking up, we are going to be up high and look what? Down. Okay, this is what throws you off on this problem though. If you're going to look at an angle of depression, you can't do the problem the same way. So here's my lighthouse, and I'm way up here at the top of the lighthouse. Isn't that a beautiful lighthouse? Just kidding. Okay, so that's my lighthouse, and I'm at the top. Now, if I'm at the top of the lighthouse, normally problems we've done are down here. So if I look straight at it, I'm looking straight at the ground. But if I'm looking straight out, I would look this way. So this is what we call my line of sight. Be sure you have this to get credit. That's my line of sight, right? Well, I'll show you what part. The second part. And if you're going to actually do an angle of depression, you're going to look down how many degrees, guys? So instead of looking straight out, you're going to glance down. And this is the mistake kids make. So I'm not going to look this way. I'm going to look down here. Which angle then, and I'll use this because I have to erase it. Which angle is 39 degrees? The green angle or the black angle? Wait a minute. I'm looking out. And I'm going to glance down 39 degrees. Isn't that weird? Good. Okay, so if you think about it in terms of real life, I'm looking out. I'm going to glance down 39 degrees. So what is actually, how do I actually find this black angle here? Excellent. The whole thing is 90. So to find the black, I have to take 90 minus 39 degrees. Are y'all seeing how it's kind of weird? Okay, I'm going to erase that and actually put it on my own paper. So you have to show me, that's what I meant by that. So let me show you what you have to have. You have to show me you understand that this is 39. The angle of depression is 39. Then you have to say, okay, I know that's 39, but to do the problem, who cares that that's 39? That's not going to help me find any of the answers. I need the inside angle, and you guys already told me that this would make a right angle, correct? So to get this side, we're going to do 90 minus 39, which is 51. That's the angle you actually need also. So I'll be looking for both of those so that you understand that's what it meant. Then it tells me that it's 345 feet above ground, so that's 345. How far away horizontally is the boat? So I'm looking for this measure here. Okay. Now, for this particular problem, I have an angle, I have its opposite again and its adjacent again. So what are we going to use again for this one? A lot of times we use tangent, but not always. So tangent of 51 degrees is 51 degrees opposite, which is x, and its adjacent, which is 345. Multiply them together, and you get 426.04. Don't forget your unit of measure, feet. Number 5. A wire stretches from the top of a building to a point on the ground 27 feet from the base of the building. So here's your building, and you got a wire that goes from here all the way to the ground. And it says it's 27 feet from the base of the building. So this is 27. If the wire makes a 57-degree angle with the ground, where am I going to put that at? Obviously, on the ground. Find the height of the building, x, and the length, it's asking for two things, and the length of the wire. There's two questions going on here, right? So the building height and the wire were two answers, not just one. Let's find, here's my angle. Let's find x first. X is opposite over what, guys? This is its opposite, and this is its adjacent. If you're still not sure, you can label it. Here's my 57, so this is the opposite. This is the adjacent. What is the y going to give us actually this time? The what? What's y called? Thank you. Come on, guys. Participate. The hypotenuse, right? So let's find the first one. Let's find x, the height of the building. You ready? So tangent of 57 equals opposite over adjacent. That's the formula for the height of the building. What about the height of the wire, the length of the wire? Here's my angle. What do I have? I have its adjacent, and I'm looking for what this time? What does adjacent and hypotenuse use? Cosine. So cosine of 57 equals the adjacent over the hypotenuse.
We also do, you do right there. Yeah. Okay, that's what I did.
Now then, for this particular problem, but hey, you do have to understand though that this would work, because sometimes they only gave me the adjacent and the hypotenuse. You'd have to understand it would take the cosine of it.
Right.
Okay, as long as you get that fine. To find tangent, you're going to do, to find the building, you do tangent 57 times 27. You'll get 41.58. Okay, but this one is different. How do I solve when the variable's in the bottom? Yeah, you flip it. So y actually equals 27 divided by cosine of 57. And so y is 49.57 feet. Let's move to problem 6. Okay, actually, guys, we're going to skip 6. I don't like its wording, so let's move to 7. A bird handler carrying a treat looks at its bird flying 578 feet in the air. I would never get that bird back. Okay. At an angle of elevation of 21 degrees. Okay, so you're on the ground right here, correct? And your bird is an angle, so here's the ground, and your bird is up here. 21 degrees. I drew this triangle maybe backwards than you, but it's up to you on how you draw it. And it tells us that the bird is 578 feet in the air. So here's the height of the bird. And it wants to know what's the horizontal distance. I'm asking for the hypotenuse. No, horizontal would be this distance. Okay. So to solve this problem, we have an angle. We have its opposite and its adjacent. So its opposite and adjacent use? Tangent. Tangent of 21 equals 578 over x. When x is in the denominator, that's when you divide. So to solve x, you're going to do 578 divided by tangent of 21. I got 1505.74 feet. Okay. Now, I'm going to pause the video again, and I'm going to let you all try to set up number 8. It's another one of the harder ones, the angle of depression. Okay, so this is an angle of depression. So a penguin's on a cliff, so draw your cliff, and here's your penguin up here. Here's the hint for angle of depression. You have to take into account that your normal line of sight would be here. This is your normal line of sight. An angle of depression means you're looking down. What throws you off is you just want to think, okay, then that angle right here is 48, but it's not. This is my normal line of sight. So if I'm looking down, this is the angle that's 48 degrees. Do you see the difference? Not here. To get this one, you have to take 90 minus 48. So to get what's inside, you do 90 minus 48, which is 52. That's your angle you need. 42, I'm sorry. Now then, it spots a fish at an angle of depression of 48 degrees and a horizontal distance of 210. So the distance from the penguin to the fish isn't 210. The horizontal distance is 210. How high is the cliff that the penguin is sitting on? So this is the cliff height. This is my angle. So I've got an opposite and adjacent. So again, we're going to use tangent. We use tangent a lot, but not always. So don't assume. You have to divide. Remember, when your variable's in the bottom, you divide. So the height of how tall the penguin is, the cliff, is 233.23 feet. Right, number 9. A wire from the top of the party tent makes an angle of 63 degrees with the ground, and it touches the ground at 237 feet. How high is the tent? All right, I'm going to let you try it and I'll walk around and check. Okay. Let's look at number 9. The wire from the top of the party tent makes an angle of 63 with the ground. Okay, it's with the ground. So here's the top of the party tent and there's the ground. So there's the wire. It is 237 feet from the tent. 63 degrees with the ground. How tall is the tent? Opposite over adjacent's tangent. So tangent of 63 is again the opposite and the adjacent of that angle. Multiply them together. See what I'm saying? Let's go to 10. Steps to an entrance of the school rise a total of 2 feet. They are to be torn out and replaced by a wheelchair ramp inclined at 12 degrees. How long is the ramp? Okay, we're asking about the ramp. So if you have stairs, right, there's your stairs. But instead of stairs, they're going to change things up and they're going to put a ramp here. Right? How tall are the stairs right now? 2 feet. And it's replaced by a wheelchair ramp that's inclined at 12 degrees. So this should be 12 degrees. And the question is, how long is the ramp? What piece of this right triangle do they want? The what? I heard you. Right. They want this part. That's what I was saying. You can't always use tangent. If you're looking for the hypotenuse, you can't use tangent. So here's your angle. They gave us the opposite, and they're looking for the hypotenuse. What uses opposite and hypotenuse? Sine or cosine? Cosine is adjacent. So we need to use what? Sine. Sine, remember SOHCAHTOA? Sine uses opposite and hypotenuse. So the opposite of our angle the opposite of 12 would be 2, and we don't know the hypotenuse. To divide, 2 divided by sine of 12. So the ramp was 9.62 feet. Right, now, 11. 11 is another angle of depression. So I'm going to pause it and see if you can build your angle of depression again this time by yourself. If you're going to make an angle of depression, the helicopter is obviously up in the air. Okay, his line of sight for the helicopter would normally be this way, but he's looking down at something. I don't know, he's shining his beam. So, and it says he's shining at 56 degrees down. But here's the height of the helicopter, and there's the distance horizontally. Here's whatever he's looking for on the ground. If this is 56, then to find the missing angle, together they make 90. So this angle here is 90 minus 56. And then it's asking us, how high is the helicopter above the ground? And it tells us that the beam is 342. So you know this is 342, and it wants to know how high it is. So I have an angle. And what 2 parts of the angle do I have? I have its hypotenuse and its what? Excellent. It's adjacent. This is the hypotenuse. And this is the adjacent. And I'm talking about of that angle. So to set up your equation, you're going to say, if I've got an adjacent and hypotenuse, that's cosine. Adjacent and hypotenuse is cosine. So cosine of 34 is the adjacent x over the hypotenuse 342. Since x is on top, all you're going to do is take cosine of 34 times 342. Okay, 12 gets a star also, it's tricky. The length of the base of an isosceles triangle is 35 inches, and each base angle is 41. All right, what does an isosceles look like? Right, it's got, 2 sides are the same, correct? Then it tells us that all the way across the bottom, so the distance from here all the way to here, is 35, right? It also tells us that the base angles are 41. Well, the base of the triangle is down here, so that means that this is 41 and this is 41. Do you agree? And I want to know the sides. Well, SOHCAHTOA only works on what kind of angles, guys? Right triangles. So in order to get a right triangle out of this, watch. If I draw a line right down the middle, and I put this mark here, I'm going to have a right triangle, correct? Let's just look at this half. Because it's an isosceles triangle, and I cut this line in half, the whole thing was 35, and this side is only 17.5. Do y'all see it? And I want what measure? The adjacent, the hypotenuse, or the opposite? What measure do I want? Okay, look at the picture. It says, what are the two sides? So I'm looking for these two sides. So I'm looking for the hypotenuse. So I've got my angle. Is 17.5 adjacent or opposite of the angle? It's beside. So I have adjacent and hypotenuse. Which of these use adjacent and hypotenuse? Cosine. So cosine of my 41 degrees equals my adjacent value over my missing hypotenuse. When x is in the bottom, you divide. So 17.5 divided by cosine of 41. So you get 23.19 inches. That's the distance of the height of the triangle. Not the height, I'm sorry, the side. Alright, we have two left. We're getting closer. Look at 13. An airplane pilot wants to make an approach to the airstrip at an angle of depression at 12 degrees. So here's your airplane up in the sky. If he was looking straight, that would be his line of sight, but he's not. He's looking down. And that means that from where he normally looks down would be a normal 12 degrees. How far horizontally from the airstrip should the plane be descending? So there's my plane height, which is 15,800. How far horizontally from the airstrip? Where does my x go? The hypotenuse or the base? And to get the measure, you do 90 minus 12, which would be 78. You have an angle, it's opposite, and it's adjacent. So tangent of 78 equals opposite over adjacent. How many of you tried 14 yet? Look kind of weird?
Yeah.
What's different about it? Where's the girl standing this time? Look at it. Student looks out the second story, right? I personally, some of you can, depending on your reasoning skills, I had to draw a picture. Here's a school building, and here she is in the second story window, right? And she's in the window, or he, whatever, and he's looking up at this flagpole. Here's my beautiful flagpole. Okay? And it says that the student sees the top of the school flagpole at an angle of elevation of 20. So here's the eyesight of the girl, and she's looking here at 20 degrees. And this is the student is 15 feet above the ground and 50 feet from the flagpole. So the distance from the girl to the flagpole is 50 feet. He wants to know the whole entire height of the flagpole. Well, what part of the flagpole height can I find right now? The part of the sky, right? Opposite over adjacent. That's only going to be from where she's standing up. How can I find from where she's standing down?
15.
Yeah, so this is 15. So all I have to do is find x. Do you all understand what it's asking? Okay, so opposite over adjacent, so tangent of 20 equals x over 50. It was just a little bit more challenging. So a, or x, whatever your side is 18.20. Take your 18.20 and add the 15 feet she is in the air to give you 33.2 feet.